Graph the function shown. Identify the amplitude, period, domain, and range. F of x equals 3 cosine of pi times x minus 1. I'll start off with the amplitude. The amplitude is 3. And the period of the function is 2 pi divided by the number in front of the x, which is a pi in this case. So the pi's cancel out. Period is 2. Okay, so what I'm going to do is I'm going to change these labels on the x-axis. Instead of pi over 2, we'll have 2, then we'll go 4, 6, 8, like that. And negative 2, negative 4, negative 6, negative 8. I'm changing these because since the period isn't going by pi, it's going by integers. We want integers to be represented on the x-axis. Okay, now we have the amplitude and the period. We can go ahead and start graphing the function. So I'm first going to graph the function without the other transformation. In this case, it's x minus 1, and the minus 1 is going to be a translation of 1 to the right. But I'll do that after. So the amplitude is 3. We'll start up here at 3. And then the period of the function is 2, so at x equals 2, we'll have the maximum again. And then I'll just use my understanding of the shape of the cosine function. Halfway in between the maximums is the minimum of negative 3. Halfway in between those is the zeros. Okay, so this would be one cycle of the function here. And I'll just do a couple more. And we'll do one over this way to the left. All right, now I'm just going to do dashed graph here. It's a little bit difficult to graph this one because it's so steep. The challenge is to try and still make it look rounded. Okay, so that's the basic idea for the non-translated function. Now we have this shift of 1 to the right, or a translation of 1 to the right. So that means every single point here is moving over 1. So I'm going to translate the key points first. 1 to the right, 1 to the right, 1 to the right, and this maximum here, 1 to the right. Now I'll translate the minimums 1 to the right. Okay, now I'll translate the zeros 1 to the right. And actually, when you translate the zeros 1 to the right, since they're 1 apart, they actually all stay in the same place. Sort of. I mean, you translate them 1 to the right, but they still appear to be in the same place because there's another 0 that was there before. Now I have all my key points. Say this one's particularly difficult to sketch because it's so steep. And you're trying not to make it look like V's, you're trying to make it look like U's. You need a 0 here. Okay, so and the pattern of the function does continue in both directions, but at least this gives you enough of an idea to see what the graph will look like. Now, if you're comparing the red and the blue, it almost looks like the red is just a reflection of the blue. And, well, that's because we translated it half of the period. So the maximums became minimums and minimums became maximums. So if you translate this cosine function half a period, it really is the same idea as a reflection, although the function is written differently. Okay, so let's look at the domain and the range. The domain for this cosine function, since it continues forever in both directions, is just x is an element of the real numbers because all real numbers are in the domain. And the range, because there are maximum and minimum values, we have to look at that. Y is an element of the real numbers such that the minimum value is -3, the maximum value is 3, so y has to be greater than or equal to -3, less than or equal to +3. Okay, so the amplitude was 3, the period was 2, the domain is x is an element of the real numbers, and the range is y is an element of the real numbers, so that it's between -3 and 3. And there's the graph.